Baik, selamat sore semuanya. Perkenalkan, nama saya Gerald Sahat Katunya Manurung dari kelas Metode Numerik-01 dan pada kesempatan ini saya akan mencoba menjelaskan mengenai pertanyaan kuis metode numerik sebelumnya dan akan ditambahkan beberapa contoh persoalan engineering sebagai requirement untuk memenuhi kebutuhan penyelesaian tugas besar. Oke. Izinkan saya untuk share screen sebentar. Baik, sudah di-share. Oke. Untuk soal penyelesaiannya yang pertama, saya akan mencoba menjelaskan dalam bahasa Inggris. Because English writing is encouraged, so speaking in English is also encouraged. The first questions are: elaborate your understanding of conscious thinking using the I5 concept. Okay, uh, let's move on to answers. Okay, for the first questions, elaborate my understanding. So my personal understandings are the conscious thinking is very well used in the I5 concept. So to elaborate it furthermore, firstly, I would like to break down the fundamentals of using the conscious thinking in the I5 concept that requires two things, which was brainware that allows us to think logically and critically about a certain problem, and also using hardware that we use to manage or control our thoughts. And secondly, um, after we know the fundamentals, it also requires to live in higher power, God. So in order to break down the concept, I would like to compare it to another framework. And in this occasion, I'm using the mic framework. First of all, the die 5 start with a starting point and then comes with an intention, which we set our objective to focus us in order for us to praise the God's creations. And then we came to the next step, which was initial thinking about the problem. We decompose, we find the pattern of the problem, and then we understanding the nature about the problem. Moving on, we came to the next step, which was idealization. We created the modeling for the problem, and then we provide some assumptions to solve the problem. And after that, we write all the equation or model that is required to go to the next step, which was instruction set, that we set some algorithm or completion steps. And after that, we found the rising problem, which divided into two. The first one is structured problems, which was the problems that we're defined or the problems that we would like to solve. And the unstructured problem is the problem that arises out of nowhere. And it's some kind of like something that's unpredictable that we must solve. And after that, we can come back to our starting point And then furthermore, go down to intention, initial thinking, the idealization and instruction set, and so on and so forth. And to compare it, as I said, I would like to use the mic framework. Also begins with the starting point, and then we define the problems, which is, yes, the definition of the problem and the objectives that we set, and ski, scope of the definition. And then we measure it, which in this step, we collect some data and we select the metric system that was used to solve the problem. And then we analyze it. So we find the root cause of it. And then we making some hypothesis to test it. And then we came to data validation. Moving on to improve, there's an option where we can modify our design. If we would like to modify it, we said yes, and it came back to the analyze step. And if not, we go to the next step, which was improve. In this step, we generate some solutions and then we implemented it. And the next step was control, where we monitor our systems and we standardize it. We making some standardization and we the documentate. We documented it, documentation, and then it ends with the ending point. So if we compare the two framework or the two concept between the i5 and the mic, as you can see from the screen, the define, the measure, and the analyze step of the mic framework also found in initial thinking steps, but also the improve and control steps is found in the idealization and the control is in instruction set steps. But the one that can be getting the upper hand, a little upper hand between the two framework is that the die5 concept offers us the freedom to go back to the starting point. And on the other hand, when we want to modify the design using the mic framework, it only offers us to go to the analyze step. Okay, moving on to the next question. Consider a problem an engineering problem in the engineering field that is required to solve using numerical method using die5 to deal or solve this problem. Okay. Where is my file? Okay. For answering the question, the second question, the engineering problem that I would like to solve first is the how to what at what time it is required to empty a tank. And the problem scheme are like this. There's water in the tank. There's two area and there's a difference in velocity, also difference in height, and so on and so forth. After the problem scheme are showcased, the next step, which was intention, is that I'm intended to find the time it requires, the tank requires to empty in order to increase my understanding about the dynamics and beauty of God's complexity creations are. And the next step is initial thinking about the problem, where I make some assumption. I make some notes that the tank has a height of h. I labeled it h, and the tank is filled with water. The fluid is water. And the next step is idealization, where I define some assumption that the height is 25 meters, but the first radius is 4 meter, the second radius is 1 meter, the smaller one, the exit radius. And the E is stands for potential energy plus the kinetic energy plus the internal energy, where the formulas are mass times gravity times height plus half of mass times velocity squared plus u, where the internal energy in here is zero. Because in the initial thinking, we define that there are no heat or work that's generated, and there's also no internal energy. And the um, the differential of, of energy about time is equal to heat plus work. There's no heat, there's no work. And we also use the this equation, pasaman the bit, where the area times velocity of the first one is equal to second area times second velocity. And the instruction set are we find the differentiation of energy about time is equal 0, where we differentiate the energy formula. After that, we integrate it through their own perspective, and then we set the parameter where the second height is 0 and the first velocity is 0. After that, we set the first the lower boundary and upper boundary is equal to 0. We substitute it, and then we found that the second velocity is equal to root of 2 times gravity times height. After that, we use uh, the this equation, Usaman the bit, where we found that the first velocity is equal to the second area divided by the first area times the second velocity. We substitute the define where the definement, the things that we've defined in the first half, which the first velocity is equal to the differentiation of height about time with perspective to time. You can say it like that. And then the area formula, pi times r squared for the two of it. And then we substitute the second velocity to root of 2 times gravity times height. We integrate it, and using the integration, we found that the t is equal to 1 over root of 2 times gravity times first radius over second radius squared and times integral of 1 over root of height with perspective to h. We input our values, and the time it requires was found, and it is 36.12192 seconds. And that's the end of my second session. Oh yeah, and first ending of my first session, which was the number one answer. Moving on to the next question. Hey, no, we're gonna stick with that question where we add another example, engineering example that we can solve using this die 5 concept or die 5 framework. I'm already prepared it. Okay. Mm, this is the engineering problem where the, there's a airplane with these parameters, and they define that the mass of the airplane is 250,000 kilograms, and the thrust force in the engine is equal to 700 kilonewtons, and we are um, asked to determine the airplane's acceleration and the normal forces that was exerted on its wheel by runway at point A and B during takeoff. We can neglect the horizontal forces exerted on its wheel. Okay. Now, hmm, wait, let me get rid of this first. Where should I put it out? Nah, I'll just put there. Okay. First, we set our intention, which was to find the airplane first. Mm, Airplane's acceleration, and the normal force forces. Okay, in order to understand how forces act on the plane and the beauty of God's creations are. Is that our intention? Hmm, How do I? Okay, this is the first step. And then the second step is to set the initial thinking about the problem. Initial thinking about the problem, where in here we can make some assumption. Assume that there are uh, no horizontal forces on its wheel. Wait, we and then I would like to assume that there are no drag force. There are no drag force. Okay, so this is the second step. Wait, let me label label it. This is the first one. This is the second one, and then we're moving on to the third one, which was hmm, Okay, the idealization we put our models. Okay, we, we use the formula. Uh, where's my pen? Total forces acting on the x axis is equal to the mass times the acceleration on the x-axis. Okay, this is the first one. The second one, forgive me for my bad writings. Their total forces acting on the y-axis is equal to 0. And then we also use the total of moment with the respective to the centroid is equal to 0 as well. Now we moving on to the next step, which was idealization. Hey, wait, no. I mean, no, for instruction set. Okay, why can't I? Okay, this is the third. Okay, and then in the instruction set, we made a model of problem, and then uh, completion steps done. Okay, now let's make the model of the problem where we draw the forces. There are thrust. Yes, this is thrust. And then we have the weight of the airplane. We also have, wait, how do I? Okay, we also have the, oh, no, the normal force acting on the A point and the normal force acting on the B point. After we create the model, we calculate. Okay, now let's calculate it. The first one is the total force acting on the x-axis is equal to mass times its acceleration in x-axis. And we, as you can see in the model, in the graph, in the free body diagram, the force that's act on the x-axis is And the thrust force is equal to, what is this? Hmm. Hmm. Select? I don't know. Dolce? Okay. Whoa. No. Make a copy of it. Hmm. Is equal to its mass times its acceleration. And the thrust force is 700. But we are asked to determine the acceleration, so it will become acceleration in x-axis is equal to the thrust force over its mass, and it's equal to 700 kilonewton. Okay, so we are 700. Forgive me for my bad writings. Divide 250,000. 250,000. And it is equal to 2.8 meter per second squared. And then we're moving on to the next equation, which is total force acting on the y-axis is equal to 0. With this, you can see from the free body diagram, it is the normal force A, normal force B, and the weight force, the weight. Assuming that upward is positive and downward is negative. So A plus B is equal to its weight. So I'm just skipping some steps to fast forward uh, completion steps. Moving on, no, you can substitute its value. So A plus B is equal to 250,000. I pick this one, copy, and it's paste. This one multiplied by the gravity 9.8, and it gives us like 2000, no, 240, 2,450, 2,452, no, 2,452,500 years Newton. Okay, moving on to the next. step, the total moment with perspective to its centroid is equal to 0, where um, I assume that going clockwise is negative and counterclockwise is positive. So the B point is counterclockwise. The the thrust force is also counterclockwise, where the A is clockwise. The weight is excluded because it has no position. The position is exactly at its centroid. Okay. Okay. So this will be mm, okay. Okay. Um. Yeah. T times 2 plus the B times 22 A minus no, I'm just going to fast forward it. So it's equal to what A times no. Minus A times 5 is equal to 0. So the thrust force is 7. Hmm, no, there's something mistaken. No. 700 kilonewton. I forgot to add the multiplication times 10 to the power of 3. Or you can say it's 10 cubed. Mm. Mm. Mhm. Okay. So, um, okay. T22B minus 5A is equal to um, the thrust times 2, 700,000. So it's 8, 1, 2, 3, 4, 5. 2 times the 700,000, yes, 700,000, which gives us 1,400 and 400,000. And after this, we can label it. Yes, we can label it. I'm labeling this as the first equation. And then I'm labeling this as the second. No. I mixed it up. This is the first equation. You can do it other way around, but it would not be elegant. We put in the second equation. And then we do the um, eliminate elimination using the first equation and the second equation. Mm-hmm. Mm-hmm. Mm. I cannot clip it. Nah, yalah. Kita sudah tahu. A plus A plus B is equal to mm, okay. Phew. And then we can um, okay. We multiply the first equation by 5 and the second equation by 1. And we do some addition, which gives us the value of first line, the value of P is equal kecil kecilan nggak ya? Aman ya. 402 402,000 Newton, and then using this we substitute into this equation substitute the B value gives us the value where, wow, it's weird. The A, the normal force on A point is equal to 2050 oh 000 2000 and 2 million of 2 million and 50 Newton. 2,050,000,000. Okay. So we already completed the final step, which was instruction set. We found that the acceleration on the horizontal axis or x-axis is 2.8 meter per second squared, and the normal force on point B is 402,000 Newton, and the force on point A is 2,050,000 Newton. Okay, moving on to the next question. That is my addition for the second question, and the third questions are: if there is value added of DI5 use in your learning process, experiential learning, then explain it. Okay, and here I say that from the various cases that I have solved using this concept, the DI5 concept, I've noticed that every steps I did in my learning process using this concept is that it teaches me to always praise God and see or break down things metodic, methodically, methodically, methodically. By that, I can fully understand how to make some assumptions for various different kinds of problems and solving each of it using the procedure, the steps coherently. And it also helps me to be aware of my surrounding because there are many things that can be derived using this DI5 concept. Okay, for the last questions is do self-evaluation and write it down. Here it says muhasabah. Okay, and throughout almost 2 years, because I'm now in my second year, almost finished my second year in studying mechanical engineering at Universitas Indonesia. I noticed that I'm still lacking in terms of my time management skills. So that makes me struggle to balance my academic duty and my social activities. And by learning throughout my learning journey in here, I realized that I can overcome this problem by making some schedule or a of uh, reminder of it by making some priority scale, and also of which things I should do first. And I am grateful and very happy that I have a very careful and helpful friends to help and accompany me until this day throughout all of my problems, all of my struggles. And that is the end of my final session. Okay, there is all for me. Thank you for listening. Thank you for watching. If there is things that I can pick during my class and during my time in this class, is that every problem can be solved and we must praise God in order to make us stay conscious. And I also learned that there are many things that I can learn and many things that I can derive using the type 5 concept to simplify some complex problems. Okay, that is all from me. Thank you very much.